Hello everyone. So in this class, already this problem has been discussed in the last class. So uh, this is a problem where it is written the arrival is at the rate of 10 per hour and service is 10 minutes. It takes 10 minutes. So obviously the service rate is 6 per hour, and two computers here are written that there are two computers used for browsing. So that means it is a multiple server model we have discussed, and infinite queue length. But here you see the problem says that assume that in last problem there are two computers and that there are 5 additional chairs for waiting people to sit, and that people do not join the line if these chairs are full. That means it is restricting the number of customers in the queue. Clear? So this is a model of uh, multiple server, multiple server, but finite queue, finite queue model. Sorry, queue length model, finite queue length model. Okay. So how this one is solved? So already we have seen the different formulas, like what is the value of rho, what is the value of Pn, what is the value of P naught, what is the value of um, length of Q, what is the value of length of system, then what is the value of waiting in the queue and waiting in the system. So these only things are required. So there we will not be deriving all these things, rather we will directly use that. So first of all, in multiple server finite queue length model, how do we denote it? So multiple server, so m, this is arrival pattern, that is Poisson. This m is service pattern, which is uh, exponential. C tells about the number of servers, which is here 2. N is the number of customers restricted in the uh, queue, and this infinite is population. So this is the model. So here queue length is restricted to n customers. Customers leave the system without joining it if the number in the system equals n. So actually what is n? Here it is written if the number in the system equals n, means n is basically the number of people in the queue plus number of people who are getting service. So queue length, or you can say this is n is let's suppose there are 5 people in the queue, so n will be 5 plus 2, because 2 are number of computers. So already 2 are sitting there and 5 are in the waiting line, so total n is equal to 7. Clear? Okay. Now here there are some terms like lambda n and mu n. So already we have discussed in the infinite queue length model. So no, sorry, single server finite queue length model. In that we have discussed what is lambda n and mu n. So lambda n means when there are n customers, small n customers in the system. Okay, so lambda n will be equal to lambda when n is in between 0 to n, 0 to n, capital N. Are you getting what I am saying? Let's suppose this is a server, okay, and there is a capacity of 5. It's telling 5, okay, and 1 is getting service. So if there is less than 5 people in the system, that means 3 are there. When n is less than capital N, when there are 3 people, then the arrival pattern is will be same, people can join, come and join, okay, and that pattern will be lambda. But in case when n is greater than n, that means or equal to n, that means if already there are 5 customers in the system, then what will happen, then no person will come and join this queue. Is it clear? So then the arrival pattern will have lambda is equal to 0. Okay, so this is the case. Same similar similar the service pattern. So see, if there are 2 servers, one server here and 2 servers are there, if in the queue there are either 0% or 1%, means less than 2, then what will happen, the service rate will be how much, it will be like for one server has service rate mu, so 1 into total number of customers, or you can say, let's suppose, just take this example, there are 5 servers, okay, and there are 3 people. So what will happen, how much is the service rate, so mu n will be equal to, see, this customer will go here, so here is the service rate mu, this will go here, so here is the service rate mu, and this will go here, so here is service rate mu, so total is 3 mu. If there are 4 customers, then this will be 4 mu. If there are 5 customers, it will be 5 mu. But if there are 6 customers, then still 5 will be getting service, but 1 will be in the queue. So 5 will be getting service, that means the server service rate is 5 into mu. So any number which is greater than c is the number of servers, so any number when it is greater than or equal to, then the service rate will be c into mu. So this you have understood, I think. Okay, now what is rho? Rho is equal to lambda by mu. Okay, so here in this case lambda by c mu should be less than 1. So this is actually this is a finite queue length model, so it is not required that this should be less than uh, 1, so nothing to worry about this. Okay, okay, Pn is equal to rho to the power n by n factorial into p naught. This formula we have already solved for the multiple server infinite queue length model, so there is nothing to worry about it. This is the same problem where p naught, now here the formula will change. Okay, we have discussed the, if you can remember, you can just go and check your notebook and see that what was the formula. So this per term was there, this term was there, this was there, and this was there, but this term is extra, okay, which will be added, where n is equal to 5, that is 7, okay, for this problem. So from here we can calculate p naught and put this p naught here, and we will calculate pn. Pn means when there are n customers, so what is the probability of n customers in the system. Okay, so this formula is for it's actually for rho which is not equal to c, or you can say rho by c is not equal to 1. But if rho by c is equal to 1, generally it is less than 1 or greater than 1, but it should not be equal to 1, then this formula will be used. If it is equal to 1, then what will happen, actually here if you see, if it is equal to 1, then this will become 0. Okay, so it will become indefinite, so that's why the formula will change. Okay, this formula is used. Basically this mostly this one is not used, like you will not get this kind of problem. So anyway, now next we have got the p naught. Now lq, that is length of q, so this lengthier one we have seen already, this term we have seen in case of infinite q length into p naught, but this one is extra. Okay, this one is extra, so this one is added, so already So now LQ we have got. Now we know LS is equal to LQ plus rho E. Now see, in case of finite queue length model, we know effective arrival. So already we have discussed about this, that arrival will change when n is less than capital N, or number of customer is greater than capital N. Based on that, n changes, lambda changes. So effective lambda is equal to 1 minus Pn into lambda, because Pn means probability that there are n customers, capital N customers in the system. So as soon as this is the probability that the person will not join the system. Are you getting? So that's why the effective lambda will be this much. So we will put it here, rho E, we will calculate lambda E by mu. So LS will be equal to LQ plus lambda E by mu. Now WS, that is waiting time in the system. Waiting time in the system, that is equal to, we know the formula, LS is by lambda E. Waiting time in the queue is LQ by lambda E. So take an example, the same example which is given here, that two computers and five additional chairs, so 10 arrival, and 10 minutes means 6 per hour is the it's the service time. So put it that lambda is equal to 10 per hour, mu is equal to 6 per hour, C is given, n is equal to 5 plus 2, 7. Probability that both the computers are free when a person arrives. So both the computers are free means there is no customer in the system, that is P naught we have to calculate, and then we know the formula of P naught. So just put it there. So you see, so n is equal to 0 to C, how value of C is 2, so 2 minus 1, 1, that means n is equal to 2, n is equal to 0 and n is equal to 1. For that we have to calculate. So n is equal to 0, put it here, how much, rho to the power 0, 1 by 0 factorial 1, so this is 1 plus when n is equal to 1, so rho to the power 1 by 1 factorial, that is rho only, and put the value of C is equal to 2 and n is equal to 7. So this will be the value, so just by putting there, rho is equal to uh, lambda by mu 10 by 6. So we got the probability that both computers are free is 12%. Second is probability that a person can use a computer immediately on arrival. One person is coming and he finds a computer. When it is possible, when either there are two chances, either there is no customer, so P naught, or there is one customer, so one computer will be free, so P naught plus P1. So we have to calculate that, and P1 we know that Pn formula already we have seen, rho to the power n by factorial n into P naught. So put it there. Okay, so probability that there is no queue on arrival. No queue means there is no queue, that means there is a chances that there is no person in the system, or there is one computer which is busy, or there are two computers in the are busy, and uh, apart from that there is no other person. So all will be added. This much is this is 0.32 for it, plus this is, we have to put n is equal to 2 here, so rho square by 2 P naught. So we will get this one. Expected number in the system, LS is equal to LQ plus lambda E by mu. Now LQ ka formula we know, this is the lengthier one. Okay, so see, one point is that lambda E first calculation, let's see the calculation. Lambda E, what is lambda E? Is 1 minus Pn by Pn into lambda. What is Pn? Pn is equal to P7, that is rho to the power 7 P naught. Actually rho to the power 7 divided by 7 factorial. Okay, uh, 1 second. Okay, here it is, this is the formula. Okay, so just put that one, or otherwise you can calculate in this way also, but better use that formula and get this value. Okay, here I'll explain what is this actually. See what happens, that I was telling that lambda, what is the arrival, this is the arrival pattern, you know. So arrival pattern after lambda 7 is equal to 0, because as soon as there is 7% in the system, then this will become there will not be any lambda. So lambda 0 means there is no customer in the system, then arrival rate will be lambda only. Okay, so this is total how many lambdas? 7. So lambda to the power 7 divided by, now this is what mu. So mu is there, that we have seen already how the mu follows here, mu. So when n, actually here in this problem, n is equal to sorry, c is equal to 2. So mu 0, how much will be the mu 0? Mu 0 means there is no customer in the system. So if there is no customer in the system, so mu 0 will be 0, there is no service actually. So mu 0 is equal to 0. When one customer in the system, then it will be mu. When two are there, 2 mu. When three are there, then 2 mu only. So like that, 2 mu means where mu is equal to 6. So put it here. So 2 into 6. Total how many? 2 onward. This is 6 total. So 2 into 6 to the power 6. And mu 1. What is the value of mu 1? Is equal to 1 into mu. And 1 into mu is equal to 6. So this formula is already given. So if you don't understand that formula, that explanation, then use simply this formula and get the value of Pn. So we have got the Pn value. Now put it in the lambda e and get the lambda e value, and put it there in the ls and get the value of length of system. From here we can get waiting time in the system, and that is 0.3099 hour. So convert it into minutes. So this is how the problem is solved. So what I wanted to say here, that this is a little bit lengthier one, although actually it is in the syllabus, but till now there is no question asked in the previous year, so nothing to worry about this. I have explained this one because you have to know this. Okay, in the latter stage when you will be using this method, then you should be familiar of this one. Okay, so that's why this one is explained. So nothing to worry if you do not remember these formulas. uh, this is not most probably this will not be coming in the examination. Okay, but you, if in examination it comes and they are giving this LQ formula, they will give, so you must be knowing what is the, you know, rho, what is the value of c, what is the value of n. Okay, so you can, so that easily you can put the values and you can you know, the solution. Okay, so we will end here and solve the quiz which is given in the email. Thank you very much.